Okay, Assalamualaikum class. Today we will continue with the second applications of integration. So that is the volume. Right. So in topic volume, we have several cases. Okay. The first one is volume for the solid object. Okay. And we also have the case for the volume of the hollow object. Hollow object means you have a solid object with a hole. Alright. Next we have three methods that we will use in solving the volume. Okay, so the first one is the this method. Okay, this method is used for the solid object, and we have washer method. Washer method is used to find the volume of a hollow object, and also shell method is also used for the to find the volume of the hollow object. Right. Okay, so for this method and washer method, it is quite similar. Okay, and it is named as the volume of revolution. Okay, volume of revolution. Okay, why? Because the shape, okay, the shape of the shaded region can be generated by the revolving the plane region about the axis or the lines. Okay, so the axis or the lines given will be called as the axis of revolution or the line of revolution or revolving line. Okay, so later on we will see in the examples. We will start with the volume by this. Okay, so for volume by this, the formula is given by V is equals to pi integration of radius square from A to B, so it can be dx or dy depending on your revolving line. So either it is dy or dx, it is depends on the revolving line. Right. Okay, so if your revolving line is on the x-axis, okay, if it is on the x-axis, then you will use top minus bottom. Alright, so you will use dx. That means everything will be in terms of x. If your revolving line is on the y-axis, then we will use dy, meaning it will be right minus left.
Okay, now let's look at the formula of volume by this. Okay, we have two formulas. That is, the first one, either you will use the top minus bottom, and the second one, either you will use right minus left. Meaning here we have two cases. Okay, let's see for the first case. Okay, the first case, let's say we have a graph here. Okay, and it is revolved on the x-axis, or it is revolved parallel to x-axis. Okay, look at there, we have the revolving line. Okay, so for area, we will assume the shaded region, okay, that is bounded by the given curve, okay, is rotating to 360 degrees. Okay, so rotation line or the revolving line is parallel to x-axis for this case. Right, so what happened, it will be, okay, let's say it is rotating on the revolving line, okay, here. Alright, so the given revolving line is parallel to x-axis. Okay, so now we will have, supposedly the formula will be in the form of top minus bottom. Okay, and if you draw, it will be in the form of three-dimensional. Okay, so it will be like this one. Right, it's just like a three-dimensional object. Okay, a solid object. Alright, so what happens if you have the case where the revolving line is parallel to the y-axis. Okay, look at here. Okay, if your revolving line is parallel to the y-axis, okay, and we assume that the shaded region is rotating on your revolving line there, okay. So this is illustration that we can see if the shaded region is revolving or rotating on your revolving line that is parallel to y-axis. Okay, look at here. Alright, if we draw, it's like a three-dimensional object, this one. Okay, alright. So what is the formula? So the formula for the first case, or first diagram, it will be your radius is top minus bottom. Okay, so when it revolve, okay, when it revolve here, so this will be the radius, right? So this is your radius, which means this one will be the radius. Okay, that's why we use the radius is top minus bottom. Okay, if you want to write the formula, then the formula will be volume equals to pi integrations from, so let's say this is A, this is B, from A to B, okay, and it will be top function minus bottom function dx, and everything will be in terms of x. Okay, next. Okay, for case 2, it will be right minus left. Okay, this is your radius. Okay, if from your diagram, it will be this one. So this one will be your radius, which means it is right minus left. The radius is just like your area, the formula of your area. Okay, so it will be right minus left. Then now the formula of V will be integration of pi, so pi, it can be in front or inside your integration. Okay, so pi A from B will be right minus left dy, and don't forget we have square here, pi r square. Okay, so the formula is we get the formula from the circle formula, pi r square. Okay, it is pi r square. Okay, this one, it is pi r square.